Hey you guys, in the last video we created an init mat and print mat. We have it printed. We also have our make file for compiling our programs and running them. So we're off to a good start on this example, but so far we've just created mat1, our first matrix. So in this video we're gonna go about creating mat2 and result. So we're first gonna go about result, and mostly that's because it's going to be cut and dry, pretty much the same as mat1. We're going to be using the same methodology. So here we have our second matrix, which we're going to call result. So then I'll have to change all of these to result. And here it is. So here I have matrix 1. I've initialized every value inside of the matrix to 2, and then here we print it out. I print a new line for clarity. So then here we have result. So result is actually going to be a 2 by 3 matrix. So let's note that down. So here I declare the rows and the columns, and then here I allocate. In this line I allocate for the double pointer, and I use result.row, so that way I stay consistent in between the rows that result has and the rows that I want to allocate for data. Then I go down here and I have my for loop where I go for each one of the rows and I allocate the columns now. I initialize the matrix with 0, and now I'm going to print that result. And after that, I free it. So I go here, I free all of the data from result, as I do the same thing with mat1. So why don't we type make? Oh, I misspelled print. As should be printf. It's all compiled. That's pretty good. We have matrix test. We run it. This is good. We have our 2 by 5 matrix here. We have our 2 by 3 matrix here. I'll actually use valgrind to double check that I have freed my memory correctly. So we're running valgrind. Excellent. All of the heap blocks were freed. No leaks possible. This is awesome. This is what I want to hear. So we're going to get a little bit more ambitious now. So here I created, mat1 and result. They're both matrix variables that have been created on the stack. So one thing that I can do is that, well, why don't I create matrix from the heap? So how will that work? That sounds easier said than done, right? Well, kind of. So the only disadvantage that we'll have here is that we cannot use init mat to initialize our matrix with values. We'll actually have to initialize the values ourselves. But first let's look at the declaration of our dynamically allocated matrix, which is going to be called mat2. And here we are. So how do we go about actually dynamically allocating for mat2? Well, for me to dynamically allocate the data, I need to make mat2 a pointer to a matrix. So then I can call calloc like normal, and now I'm going to cast the output as a matrix pointer, right? As I would for a double pointer and an integer pointer and a float pointer. Here I have a matrix pointer. So then I call malloc. Since I'm only allocating for one structure, I do 1 times the size of. But now, instead of using the primitive data types like a character or an integer, I'm using the structure. And this works fine. Here I'm able to allocate the size of matrix. And this allows me to dynamically allocate data for a matrix. And pretty much if you have another structure, like, I don't know, you had like a list or a stack or a queue, and you need to dynamically allocate those, you just cast it as a list pointer or a stack pointer or a queue pointer, and then you get the size of your list, stack, or queue structures. Right, so the general use for malloc is just you need to specify how many variables you want to allocate for. Let's say you want either a singular, you want to have your dynamically allocated variable as a single value or an array. You specify that with the number here, but then you cast the data type that you want to dynamically allocate for here. So anyways, what comes next is exactly, well, it's almost similar to what we did before. So here I'm defining the row and the columns for the matrix. Instead of using the dot operator, I'm using the arrow operator because mat2 is a pointer. And here I do the same. I dereference mat2 to access data. And here I do the malloc and I allocate for the double pointer to a double. The only difference here now is that instead of using, matrix.row, I dereference mat2 because again, it's a pointer. I do some more dereferences instead of using the dot operator. The code here is largely similar, just instead of using dot to access the members, I'm using the arrow because mat2 is a pointer, where an above with result in mat1, they are not pointers. Because mat2 is a pointer, if I actually pass it to init mat, I will get a copy of the pointer. In order for me to pass that by reference, then I'd have to make the input for init mat a double pointer. And you know what? That becomes very, very complicated very fast. So I'm going to keep it simple. And just because mat2 is the only dynamically allocated variable that I'll have for the program, I'm going to take the guts of init mat and I'm just going to put them here. I'm going to fill the contents of mat2 with the value 3.0. So we'll have a 5x3 matrix that are all values that are equal to 3.0. Then I'm able to pass print mat here. Because I'm not accessing the values and I'm not editing the values, I'm just reading them. It's no big deal that I pass by value here because it's okay if I take a copy of the pointer here because I'm not trying to edit it. And of course, I'm freeing mat2's data because that's important. And lastly, while I free the data inside of it, I need to free mat2 itself, right? Compared to the other freeings, because result and mat1, they're statically allocated because I just declared them as those types of variables. I don't need to free them, but because mat2 is dynamically allocated, I need to. So what does this mean now? Well, why don't we check that creating a second matrix result and creating a dynamically allocated version called of mat2, let's check that we are able to initialize their values and that we have correctly created those variables. Here I just needed to compile main.c because that's the only file I edited. And now I will do matrix test. I will run it. That's good. We have our 5x3 matrix here. Not bad. So why don't we run this with valgrind to make sure that we have no memory leaks. And awesome, we don't. All of the heap blocks are freed. No leaks are possible. So we're making some really good headway on this. In the next video, I'm going to cover creating a function called multiply matrix. And we will multiply our mat1, which has these values, and mat2, which has all these values, into result right here, so that way that can have values. I'll see you there.